Hello, this is Dr. Hanaa Assil, and this is Unit 1 of October 2022 in the International AS Edexcel syllabus. So let us take a look at the first question. It says, which mixture results in a displacement reaction? So which of these is a displacement reaction? Well, let's see. Iron plus copper sulfate. Iron plus copper sulfate. You know that iron is more reactive than copper. It will displace it. So this is actually my answer. Now let's check the rest. Lead nitrate and sodium iodide. If I react lead nitrate with sodium iodide, remember that lead nitrate is the test for halides. So when we add it to an iodide, it gives a yellow precipitate. This is called precipitation reaction. Dilute HCl with sodium hydroxide. Well, this is acid plus base to give salt plus water. This is neutralization reaction. What about zinc plus magnesium? Well, zinc plus magnesium sulfate would not react in the first place because zinc is less reactive than magnesium, so it will not displace it. So A is my answer. Okay, question 2. Which mixture results in precipitation reaction? So which of these is a precipitation reaction? Well, let's look at the first one. The first one is acid plus base to give salt plus water, dilute sulfuric acid plus potassium hydroxide. So this is neutralization reaction. What about iron and calcium chloride? Well, iron will not react anyway with calcium chloride. It is supposed to be a displacement reaction, but because iron is less reactive than calcium, then there is no reaction at all. What about chlorine water and potassium bromide? Chlorine plus potassium bromide will give potassium chloride plus bromine because chlorine is more reactive than bromine. So this is actually a displacement reaction. And the last one, silver nitrate and potassium bromide. Well, silver nitrate is the test for halides also. And we said when we add silver nitrate to a bromide, it actually gives you a cream precipitate. So this is a precipitation reaction. So this is our answer. Okay, the third question says an atom of nitrogen forms a nitride ion. What are the numbers of protons, neutrons, and electrons in the ion? So actually, I'm looking at N3 minus, and he's already given you that the mass number is 15, the atomic number is 7. So if the small number or the atomic number is 7, that means the number of protons is 7. What about the number of neutrons? How do we get the number of neutrons? It is the mass number minus the atomic number. So 15 minus 7 is 8. What about the number of electrons? Well, originally the number of electrons is the same as the number of protons, but this is a 3 minus, and that means that the nitrogen gained an extra 3 electrons. So 3 plus 7 is 10. So this is our answer. Can you see that? So the number of protons is the small number. The number of neutrons is the difference between the mass number and the atomic number, or the big number and the small number. And the number of electrons is originally the same as atomic number, so the same as the small number, but if it gained electrons, then you add these 3 extra electrons to the original number of electrons, which was 7. Following? Easy enough? What is the total number of orbitals in a sulfur atom which contain at least 1 electron? Well, we need to look at the electron configuration of sulfur. So first of all, what is the atomic number of sulfur? From the periodic table, the atomic number is 16. Now, how are we going to distribute the 16 electrons? You should know that we have one S. We will put 2 in it, and then we still have electrons. It will be 2s2, and then the 2p can take up to 6. 3s can take 2. The 3p can take up to 6, but I'm left with only 4. Remember, we have 16. So these are 16 electrons that have been distributed. Now, what is he asking? He's asking what is the total number of orbitals that contain electrons. Okay, so the 1s is made up of one orbital, the 2s, one orbital, the 2p has three orbitals, 3s has one orbital, and the 3p has three orbitals, so that makes a total of 9 orbitals. Okay, which structure has the name E2-bromo-3-chloro-pent-2-ene? So first of all, we want a pent. Well, all of them actually are a pent if you count the number of carbons in the chain. How do we name an E or a Z? Remember that if I want it to be E, then the bromo and the chloro should be on opposite sides of the double bond. So if I look at A, the bromo and chloro are on opposite sides of the double bond. This is 5 carbons, so this is pent, 2 ene, double bond at 2, and I have 2 bromo and 3 chloro. So this is actually my answer. Let's look at B. B, first of all, is not an E, it's a Z. Both bromine and chlorine are on the same side of the double bond, so this is a Z. This is not what I want. What about C? C, they are opposite, but where is the chloro and where is the bromo? Remember, we need to count from the side that gives you a smaller number. So this is actually a 2 chloro 3 bromo, or a 3 bromo 2 chloro. So it's not what I want. Now what about this one? D, well, the 2 bromine and chlorine are not both on a double bond. So this is a different molecule in which you would name, this is E4 bromo 3 chloro. So this is also wrong. So our answer is A. Partial oxidation of butane in the presence of a catalyst has been investigated as a possible source of hydrogen. So he's giving me an equation of butane with oxygen. And he's saying what is the most significant hazard associated with carbon monoxide? What is the harmful effect of carbon dioxide? What is harmful about carbon monoxide? Well, you should know that carbon monoxide is toxic. It attaches to the red blood cells. So less oxygen is transported to the cells. We say it reduces the capacity of blood to carry oxygen. In any case, it is toxic. A mixture of 40 centimeter cubed of butane and 20 centimeter cubed of oxygen. Remember, this was the equation. So he is reacting 40 centimeter cubed of butane with 20 centimeter cubed of oxygen in a sealed system to form carbon monoxide and hydrogen. What is the total volume of gas in the system at the end of the reaction? Well, let's take a look. What is happening if he puts 40 centimeter cubed of butane? Remember that we can relate directly from the equation either the number of moles or the volume of gases. So if I'm starting with, the equation says if I start with 1 mole of butane, I need 2 moles of oxygen. So the number of moles of oxygen should be twice. So if I put 40 centimeter cubed of butane, actually what I need is 80 centimeter cube. So the butane is excess. If I have 20 centimeter cubed of oxygen, I will need only 10 centimeter cubed of butane. And that means the 40 centimeter cubed is excess. And that means the oxygen will react with only 10 of them. And that means I will still be left with 30 centimeter cubed of unreacted butane at the end of the reaction. Are we following? Then, okay, so butane is excess, oxygen is limited, so we're going to use the oxygen. If I have 20 centimeter cubed of oxygen from the equation, 2 gives 4 of CO, 5 of hydrogen. That means 20 will give 40 of carbon monoxide and 50 of hydrogen. And that means at the end of the reaction, the total volume of gas that I have is the 40 of carbon monoxide that was formed, 50 of hydrogen that was formed, and the 30 which was excess, 30 of butane that did not react. So all of these remain at the end of the reaction. So I end up with a total of 120 centimeter cubed. Okay, octane reacts with bromine in the presence of UV radiation or ultraviolet radiation. What is the role of the ultraviolet radiation? Remember, alkanes react with halogens in what kind of reaction? They react with it in a free radical substitution reaction. Now, what is the role of the UV light? You should realize that the UV light is the one that takes part in the first step, which we call initiation step. The UV light causes the Br-Br bond to break so that one electron goes to each Br, so it ends up forming two bromine radicals. So it forms a free radical, and we say this kind of bond fission is homolytic bond fission, in which one of the electrons goes to each of the atoms. Then one of the steps of the reaction is this. Remember that breaking up of the Br-Br bond was initiation. Then we go into what we call propagation step. So in the propagation step, the first the bromine radical that was formed breaks up the octane to form an octane radical. Then the octane radical reacts with a bromine molecule so that the bond between the Br-Br breaks up again. One electron is used to join the bromine to the octane radical, and it forms another bromine radical that continues to go. So this is called propagation step, and we said that the breaking up of the bond so that one electron goes to each atom. This is called a homolytic fission or homolytic bond break. What is the overall equation for reaction of octane with bromine? Of course, what happens when we do alkane plus halogen? We remove one of the hydrogens, replace it with a bromine, and the other product is HBr. So this is our overall reaction. A stream of liquid from a burette is deflected by a charged rod. Which substance in its liquid state will be deflected the most? Of course, when we have a charged rod, the liquid that is deflected has to be polar. So the question is, which of these is polar? Well, let's look at A. A is just pentane. Pentane is an alkane. Alkanes are not polar, so it will not be deflected. What about carbon tetrachloride? Well, each carbon chlorine bond is polar, but then they are in opposite directions, so the polarities cancel each other, so overall the molecule is not polar. What about BCl3? Also, each bond is polar, but overall they cancel each other, so the molecule is not polar. But what about CH2Cl2? Well, each CCl bond is polar and they're not cancelled. So this is the one that has a polar molecule, so it will deflect towards the charged rod. A piece of copper is shown. How many moles of copper atoms are there in this piece of copper? Well, let's see. We want number of moles. Number of moles is the mass over the molecular mass. So I need to get the mass. How do we get mass? He gives me density. You should realize that density is mass over volume. That means mass is density times volume. The density he gives me, 8.96. The volume is length times width times height, 4 times 8 times 12. So this gives me a mass in grams. Now I can use that to get number of moles, mass over molecular mass. This gives me number of moles of 54.2. Mass spectrometers are used in chemical analysis. In which region of this mass spectrometer are the ions accelerated? Do you remember this diagram for a mass spectrometer? We said what happens in a mass spectrometer? The sample enters, it is heated and vaporized, and then it is bombarded with an electron beam to ionize it. So this is where ionization happens. And then the ions are accelerated by passing through two electrodes. So this is the part that he identifies as Q. This is where ions are accelerated. 4 iron ions are present in a stream of ions in a mass spectrometer. The paths of these ions are shown. Which of these ions will follow path 1? Where is path 1? You can see that path 1 is the one that has the most deflection. And you should remember, in a mass spectrometer, the lighter ions are deflected more than the heavier ions. So which one was most deflected means which one is the lighter ion. Lighter means the m over e. So the first one has an m over e. The mass is 54 and it has a charge of +1. So that is 54. Now the other one has a mass of 54 and a charge of 2. So your m over e is actually 27. The third one has mass over e is +1. Remember the charge, +1 or +2, that is the e. So 56 over 1 is 56. The last choice is 56 over 2, that's 28. So which of these is lighter? Well, B is the one that has an m over e of 27. So this would be the one that is deflected the most. Naturally occurring chlorine has two isotopes, 35 and 37. How many peaks due to the singly charged molecular ions? Molecular means I have two of the chlorine in the Cl2. Well, if I have two chlorines, either both of them are 35 and 35, so that will give one molecular ion at 70, m over e of 70, or both chlorines are 37, so that will be another peak at m over e 74, or one of them is 35 and the other is 37, and that will give a peak at 72, and that means I have 3 molecular ion peaks in the mass spectrum. The first ionization energies of some consecutive elements from periods 2 and 3 of the periodic table. The letters used to label the elements are not their chemical symbols. And he's saying which element has only one p orbital containing a pair of electrons. Well, you should remember when you look at this kind of graph for the first ionization energy, the one that has the highest first ionization energy is the one in group 8 or group 0. And when we go down to Y, for example, this indicates that Y must be in the following period in group 1, because you're removing an electron from a bigger atom in Y, more shells further away from the nucleus, so Y must be something in group 1. Now the question says which element has only one p orbital containing a pair of electrons. Well, let's see. Group 3, remember, we have anything in group 1 is in S1. It has S1 at the end. Group 2 is S2. Group 3 is a P1 at the end, the final, the electron in the outer shell. Group 4 is in P2. Group 5, P3. Group 6, P4. P4 means I have 4 electrons. Now, 4 electrons distributed in the p orbitals. Remember that if it was just one electron, it goes into one orbit. 2 electrons, second orbital. 3 electrons in the third orbital. And then in p4, we have to pair the electron in the first orbital. So that means the p4 is the one that will have one p orbital containing a pair of electrons. That means that it applies to V. Which element is the least reactive? We said the one that is least reactive is the one in group 8. The one in group 8 is the one that has the highest first ionization energy, so that is element X. Which element has the greatest second ionization energy? Remember that second ionization energy when it is a jump from the first to the second, that means that the element was in group 1, because in group 1, Y, for example, if we say it's in group 1, that means it had 1 electron in its outermost shell. Now, if I try to do a second ionization energy, then we're going into the inner complete shell nearer to the nucleus. So you will have a huge jump in the ionization energy when you try to remove the second electron. A mass of 4.08 grams of hydrated copper sulfate was dissolved in deionized water to form 250 centimeter cubed of solution. What is the concentration of the copper sulfate solution formed? Okay, so he wants concentration. Concentration means number of moles over volume. So I need number of moles. In order to get number of moles, I need the MR. So let's do the MR of copper sulfate 5 water, 1 copper, 1 sulfur. I have what? I have 10 hydrogens and how many oxygens? A total of 9 oxygens. Can you see that? So that is the MR of the hydrated copper sulfate. I can use that to get number of moles from the mass that he gives me, 4.08. This gives me number of moles of this salt. Then what is he asking for? Concentration. Concentration is number of moles over volume. Don't forget to divide the volume that is in centimeter cubed by 1,000 before putting it into the equation. This means that my concentration is 0.0654. A mass of 2.5 grams of sodium chloride reacts with excess lead nitrate solution, forming lead chloride with a yield of 95%. What is the mass of lead chloride formed? Okay, what does he give me? He gives me 2.5 grams of sodium chloride. I can use that to get number of moles. Mass over molecular mass gives me the number of moles of sodium chloride. Then, what is he asking about? He's asking about lead chloride. So I look at the equation. What is the ratio of moles between NaCl and PbCl2? From the equation, 2 moles of sodium chloride would give 1 mole of lead chloride. That means the number of moles of lead chloride is half what we got for the sodium chloride. So now I have the number of moles of lead chloride. What does he want? He wants the yield. Yield means mass. So the theoretical mass. So if I do this theoretically, I should get how much of the lead chloride, number of moles times MR, I should get 5.94 grams of lead chloride. But then he says that he got a yield of only 95%. That means what he actually got was 95% of that. So he actually got 5.65 grams. Okay, so if he says yield, we calculate the mass, that is the theoretical that he should have obtained. But then when he says the yield is only 95%, that means he got only 95% of what he should have obtained. This question is about barium and barium compounds. The graph shows the first 8 ionization energies of barium. Write an equation including state symbols for the third ionization energy of barium. What do we mean by the third ionization energy? That means we've already removed 1 electron in the first, we removed another electron in the second, and we're trying to remove a third. So that means I'm starting with barium 2+, and this has to be in the gaseous state, to give barium 3+ in the gaseous state by removal of an electron. And remember that all of these have to be in the gaseous state. State how the graph confirms that barium is in group 2. From this graph, I can tell that barium is in group 2. Why? Because after removing the second electron, there is a large increase in the ionization energy, or there is a huge jump in ionization energy from the second to the third. That means I remove the first 2 electrons, and then in the third, I'm trying to remove an electron from an inner shell nearer to the nucleus, more difficult to remove, so it needs a much higher ionization energy. Then he says an acidified aqueous solution of barium chloride is used to test for sulfate ions. Draw a dot and cross diagram for barium chloride. So how do we draw a dot and cross diagram for barium chloride? Remember that barium chloride is ionic. Barium is in group 2. It will lose its 2 electrons in outermost shell to become barium 2+. Now each chlorine is in group 7. It needs only 1 electron. So I need 2 chlorines to take the 2 electrons, and each of them now has 1 electron from the barium, so it has an extra negative charge. Calculate the mass of barium chloride needed to form 150 centimeter cubed of barium chloride with concentration 0.2. Okay, we have volume and we have concentration, and he wants mass. So the first thing I can do is get number of moles. Concentration times volume. Of course, divide the 150 by 1000. This gives me the number of moles. Then I can get the MR of barium chloride in order to get the mass. The mass would be number of moles times MR. This comes out to be 6.25 grams. Barium chloride solution is acidified to prevent carbonate ions, giving a false positive result. Write the ionic equation for the reaction of hydrochloric acid with carbonate ions. Remember that if we have an acid with a carbonate, this gives me the salt plus carbon dioxide plus water. Now, how do I write ionic equations in general? We ionize whatever is aqueous. We do not ionize any gas or liquid or solid. So the HCl is ionized, sodium carbonate is ionized, sodium chloride is ionized, carbon dioxide and water is not. We cancel whatever is the same on both sides of the arrow, so this is actually the equation he's looking for. And without going through all of this, you should be able to know that the hydrochloric acid ionizes to form H+, reacting with carbonate ions. This gives carbon dioxide and water, and of course it has to be balanced. Give a reason why solid barium chloride does not conduct electricity. We said that barium chloride is ionic, and we know that ionic compounds do not conduct electricity when solid because the ions are not free to move. They are in a fixed position in the ionic crystal lattice, so they're not free to move. This question is about hydrocarbons obtained from crude oil. Petrol used in cars has a high proportion of the alkane, which is called isooctane. Isooctane can be formed by heating octane to 400 degrees Celsius in the presence of a catalyst. And the first question is, give the IUPAC name for isooctane. How would I name this compound? Well, let's see the longest chain, and then the other methyl groups are substituents. So we have substituents on which ones? Remember that we count from the side that gives the lower number. So this is how we count, and that gives us 2,2,4 trimethyl pentane. Name the industrial process used to convert octane into isooctane. Remember, if I have a straight chain and I change it into a branch chain, this process is called reforming. Give a reason why petrol needs a high proportion of isooctane. Why do we add isooctane to petrol? Remember, we said this is to prevent knocking or to make the combustion smoother. So it allows petrol to do a smoother combustion, or we say it prevents knocking. Another way to produce isooctane is by reacting the isooctane with 2-methylpropene. Now, the question is, draw the skeletal formula of 4 isomers of 2-methylpropene. Can you see where 2-methylpropene is? We need to draw the skeletal formula of 4 isomers. And he's saying only one isomer does not decolorize bromine water. So we want only one of them that does not have a double bond, and the other three should have a double bond. This is what? This is something that has 4 carbons. This is 4 carbons, and it should be an alkene, so I can have the double bond on one end, or I can have it like this. So if I draw it like this is cyclobutane. Cyclobutane is also something with C4H8, but it doesn't have a double bond, so it will not decolorize bromine water. And remember that either the double bond is on one end or in the middle. So in the middle means I can either have a trans or a cis. Okay, so these are the 4 isomers that we could have. 2-methylpropene reacts with hydrogen bromide to form 2 possible products. Draw the mechanism for formation of the major product between 2-methylpropene and hydrogen bromide. 2-methylpropene and hydrogen bromide is an alkene with HBr. Remember that this is what we call electrophilic addition. So how does electrophilic addition happen? The electrons from the double bond are used to make a bond with the hydrogen, and the other carbon will have a positive charge. So we're forming a carbocation. The one with the major product is the one that has the carbocation on the tertiary. So that intermediate that we have is the one that will give a major product because the carbocation is a tertiary carbocation. Now the Br minus will attack that carbocation and give the product. So when he says give the reason why your product is the major product, we say it is formed from a tertiary carbocation. So this would be more stable than if we were to put the hydrogen on the tertiary, so that the other one would be a primary carbocation. Another component of petrol contains this percent of carbon and this percent of hydrogen. Calculate the empirical formula. How do we calculate empirical formula? Remember, he says I have 92.3% carbon, 7.7% hydrogen. What's the first step? Divide by the mass number of each one. So this gives me these numbers. Then we divide by the smallest, and obviously the ratio is 1 to 1. This means that the empirical formula is CH. Then he says a sample of compound X has this mass, vaporizes at this temperature, has this pressure, and produces a gaseous sample with a volume of this. Calculate the molar mass. So if you have this kind of information, you're supposed to use the ideal gas law. Now he's asking for the MR. I can put that into the equation because PV is equal to nRT. Well, I know that N, number of moles, is mass over molecular mass. Rearranging the equation, then the molecular mass can be obtained. So let's see what we're going to put in. We're going to put temperature. Well, he gives me the temperature in degrees Celsius. Remember, I have to add 273 to change it to Kelvin. Then I can put the values into the equation for MR. So MR is MRT over PV. The mass he gives me in grams, that's fine. R is 8.31. The temperature we calculated to be 358. Over the pressure, now he gives me the pressure in kilo Pascal. I have to multiply by 1,000 because it's supposed to be in Pascal. The volume, he gives it to me in centimeter cubed. I have to multiply by 10 to the minus 6 in order to make it into meter cubed. So this gives me an MR of about 78. Deduce the molecular formula of the compound. So if the empirical formula is CH, and we calculated that the molecular mass is 78. Now, what kind of combination can I have that will give me a total MR of 78? Well, you can either guess or you can put it into an equation where I put, okay, carbon, I don't know how many carbons, so I denote it by 12x. I don't know how many hydrogens. It's a 1-to-1 ratio, so this is X. This total should be 78, and I can solve for X. So this comes out to give me that the formula is C6H6. So if you calculate the MR of C6H6, you will find that it is 78. This question is about group 4 element, germanium, and some of its compounds. Naturally occurring germanium consists of 5 stable isotopes. Explain what is meant by isotopes. What is definition of isotopes? Atoms of the same element having the same number of protons but different number of neutrons. The mass spectrum of germanium is shown. Calculate the relative atomic mass of this sample. How do we calculate relative atomic mass from the mass spectrum? You should remember, it is the mass times the percentage abundance, plus the mass times the abundance, plus the mass times the abundance, all of them over 100. So if you calculate this, this gives you an atomic mass of 72.7. Give the electronic structure of a germanium atom. Well, atomic number from the periodic table of germanium is 32. How do we distribute 32 electrons? So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. You should realize that that is the electronic configuration of germane. Germane is a compound with the formula GeH4, and he gives me an equation. Calculate the atom economy for formation of germane. How do we calculate atom economy? Remember, atom economy is the MR of what we're looking at over the total MR of the products times 100. So if we look at germane, germane is GeH4. So calculate the MR of GeH4, it comes out to be 76.6. Now, what is the total MR of the products? So this is the MR of GeH4 plus 2 times the MR of sodium hydroxide plus MR of NaBO2. The total is this. So the atom economy is the MR of what we're looking at over the MR of all the products times 100. So this gives me about 34.4%. Germane can donate a proton to ammonia, forming the ion GeH3-. Draw a dot and cross diagram of GeH3-. Show the outer electrons only. Remember, if we were to draw GeH4, that would have 4 hydrogens. He's saying he's going to lose one of the hydrogens. So he just removed a proton, but the electron that was used to bond with the Ge is still there. So we have Ge with a lone pair of electrons, and then it has 3 shared pairs of electrons with the 3 hydrogens. Remember, we have an overall negative charge. Use your answer and electron pair repulsion theory to predict the name of the shape and the bond angle of GeH3. If I have GeH3, this is what it looks like. The Ge has a lone pair of electrons, and we have 3 bonds or 3 bonding pairs. Remember that the lone pair of electron repels more than the bonding pairs. So when we have this kind of molecule, 1 lone pair and 3 bonds, this is called trigonal pyramidal, and its bond angle is about 107 degrees. Germane is toxic. Maximum permitted concentration is this in air. Calculate the maximum number of germane molecules permitted in a laboratory with a volume of 231 meter cubed. Okay, so what do we have? He's saying the maximum concentration that I can have is 0.64 grams, no, 0.64 milligrams per meter cubed. And how many meter cubes do we have? We have 231. So the total mass that I can have is 0.64 times 10 to the minus 3 to change it into grams times the total volume that we have. So that is the mass that is allowed. Then I can use that to get number of moles, mass over molecular mass. So this is the number of moles that we have. Then he wants what? He wants the number of molecules. How do we get number of molecules? It's the number of moles times Avogadro's constant. So number of moles times 6.02 times 10 to the 23 gives me the total number of moles, or the maximum number of molecules permitted in the laboratory. A halide of germanium reacts with water as shown. 1.5 grams of GeX4 was added to excess water. The insoluble germanium oxide was removed by filtration. The solution of hydrogen halide formed, HX, up there in the equation, was then added to excess magnesium carbonate, forming a certain volume of carbon dioxide. And the first question is, calculate the number of moles of carbon dioxide. What does he tell me about carbon dioxide? He gives me a volume. Well, number of moles is the volume over 24, or over 24,000 if I put it with the centimeter cubed. So this gives me the number of moles. Then he says, deduce the number of moles of HX. Well, look at the equation. Can you see the equation? Obviously, the number of moles of HX should be twice that of carbon dioxide. So that's the number of moles. Now, deduce the number of moles that reacted with the excess water. He wants the original number of moles of GeX4. Well, the equation says that the number of moles of GeX4 is what? Is the number of moles divided by 4. It is a 1:4 ratio with HX. So divide the number of moles of HX by 4. This gives the number of moles of GeX4. Then he says, use all of that to calculate the molar mass of GeX4. Remember, we don't know what is X. We're trying to find out what is X. So what do we know so far? This is the mass that he put, 1.5 grams. This is the number of moles that we calculated. So I can use all of that to get MR. MR is mass over the number of moles. So the mass is 1.5 over the number of moles. This gives me a total MR of GeX4, 214.6. So how can I get X? Well, the GeX4 has a total of 214. This includes the Ge, MR of germanium from the periodic table, and 4 times the MR of X. So I can calculate that the MR of X is 35.5. Looking at the periodic table, the one that has a mass of 35.5 is chlorine. So that means that my X was chlorine. Limonene is an oil extracted from the skin of citrus fruits such as oranges or lemons. It is found in some cleaning products such as those used to remove chewing gum. Limonene has the structure shown. Deduce the molecular formula of limonene. Of course, when he says that, you look at the structure and you try to determine how many carbons, how many hydrogens. If you do that, you will find that we have a total of C10H16. Are you able to do this? Of course, each carbon must have a total of 4 bonds. If it doesn't have 4 bonds, then you add the hydrogens in order to make 4 bonds. A few drops of acidified potassium manganate solution are mixed with a sample of limonene. State the color change. You remember, when potassium manganate reacts with something, it changes from what to what? Purple to colorless. That is, potassium manganate is originally purple. When it reacts, it turns colorless. Draw the skeletal formula of the structure of the organic product formed when this compound is carried out with excess, or this reaction is carried out with excess acidified potassium manganate. So I have this molecule. Remember, this molecule has two double bonds. Now he's reacting it with potassium manganate. What happens if I react an alkene with potassium manganate? For each alkene, I have a diol. So we have a diol forming for each alkene. Name the type of reaction that limonene undergoes, of course, with acidified potassium manganate. What is the reaction? The reaction is oxidation. On heating, limonene reacts to form two molecules of a smaller hydrocarbon Q. Now, Q can be polymerized to form R. So, a polymer used to improve the grip of car tires. A section of R is shown. So, this is the polymer. R is the polymer. And basically, he's telling you draw the structure of Q. So, he's telling you draw the structure of the monomer. Now, if we have an addition polymer like this, how do we draw the monomer? We look at the repeat unit. This is the repeat unit. Okay, remove the bonds on the ends of the two carbons and put a double bond in the middle. So this is the repeat unit of that polymer. Give two ways in which chemists can help minimize problems caused by disposal of polymers. Remember the problems caused by disposal of polymers? We said polymers are non-biodegradable. So if I want to minimize the problems, I should develop biodegradable polymers. Another problem was when burned, they release toxic gases. Then one way to minimize the problems is to remove the toxic gases produced when we burn the polymers or when we incinerate the polymers. Limonene is extracted from orange peel using a solvent. Possible solvents are hexane and liquid carbon dioxide. Liquid carbon dioxide can be obtained by allowing solid carbon dioxide to melt under high pressure. So just one advantage and one disadvantage of using liquid carbon dioxide rather than hexane to dissolve the limonene. So he's saying, what is the advantage or the disadvantage of using liquid carbon dioxide instead of hexane? Well, one advantage, remember that hexane is flammable, carbon dioxide is non-flammable, and it is non-toxic. So that is an advantage. But the disadvantage is, he said, we melt it under high pressure. So melting requires high pressure, and using high pressure is usually something that needs energy, and it is expensive. The last question says orange peel contains 1.63% of limonene by mass. A chewing gum remover contains 30 centimeter cubed of limonene. So we need 30 centimeter cubed of limonene. Calculate the mass of orange peel needed to obtain 30 centimeter cubed of limonene. So what do? He gives me the density of limonene. So I can use that to get the mass. Mass is density times volume. The density is 0.841, and he says I need a volume of 30 centimeter cubed. Remember, density is in gram per centimeter cube. So I can multiply by 30 directly. This gives me the mass that I need. Now, he's telling me that orange peel contains 1.63% limonene. That means if I have 100 grams of orange peel, it will have 1.63 grams of limonene. So how much of the orange peel do I need to get 25.23 of limonene? If we just do direct cross multiplication, then the mass that we need is 1.55 kilogram. Remember that what came out from my equation was in grams. Divide by 1,000. That means I need this, because he says calculate the mass in kilogram. Are we following all of this? Okay, that's the end of this. I hope it was useful to you. Thank you for listening.